Tonight we have a pleasure to host David Hindle, who will deliver a lecture on tunnel maintenance and repairs, as well as improvements. David has over 45 years of experience in tunnel engineering, mining and engineering geology. Following a number of years during 1970s in mining, he returned to the UK, where he was engaged by Howard Humphreys as a principal engineer on a wide variety of projects, culminating in the investigation, design and supervision of the A55 Penicle tunnel in the North Wales. Following a period of study, Dave was appointed technical director of Travis Morgan, responsible for the project management of the detailed design of Liverpool Street Station, for Crossrail, and the investigation and design of a third Blackwall tunnel beneath the River Thames. As the managing director for Dr. Zauer's company, he was responsible for the design of the shotcrete supported tunnels for complex mined London Bridge Station and the refurbishment design of Brunel's Thames Tunnel. Prior to co-founding ONTB, Dave was an independent consultant and actively involved as organizer and chairman of the regular major tunneling conferences held in the UK. As a founding director, partner and chairman of OTB Engineering, he has contributed to and managed a number of significant projects in the UK and overseas. Since his retirement from OTB, Dave has provided expert advice and expert witness testimony on a number of major tunneling projects in the UK and overseas. He currently lectures on tunneling topics to a number of universities and institutions in the UK, including MSc in tunneling at Warwick University. Dave, over to you.
That's me. Hi, is this working? Can you hear me? Yeah. So, it's a big subject, so we can get going. You're right. Tunnel maintenance, repair and improvement. It's a growing subject. It's one that's going to grow even more. There are quite a number of jobs actually going on as we speak around UK, which you never hear about really, but we'll have a look at a couple of them. So I'm going to start with this statement. It's a pretty bold statement. It's true though. I don't know if you've ever thought about it. Tunnels are the most resilient, sustainable and cost-effective civil engineering constructions ever devised, provided they're properly maintained. Not many people think about that. It'd be interesting to know how many tunnels there are that have been built for civil engineering purposes in history and are still being used or are still capable of being used. I would think you'd find it's a pretty high a remarkably high percentage. But then what about this? Well, you know, it's a pretty bold statement, but what about that thing there? Well, it's pretty old, it's pretty resilient. I wouldn't say it's particularly economic, but there it stands. What about that? Well, it's got its own tunnels. And because the tunnels are underneath the Great Pyramid, they're probably older than the Great Pyramid. It's quite a large cavern there, and you can see they've been around for 4,500 years, and they've hardly been maintained at all. And they're still in use as for tourists and archaeologists still use them. But more practically, there are these. These are called qanats, and you'll find these around the Middle East, Iran particularly. I think there are some in Iraq and maybe some in Yemen. These are aqueduct tunnels. Some of these are over 3,000 years old. They are still they've been in continuous use for several millennia. And all they're doing is collecting water from under the water table, also some runoff from fallages on the side of the hill, and then transmitting it to the land irrigation. These things are just basically, all that they do is the guys go in there and clean them out every 10 or 20 years. They're maintained by farmers mainly. And then there's this. There are other examples besides this, but this is a 2,500-year-old underground city, a complete underground city in Turkey that's still capable of being inhabited. It's capable of sheltering as many as 20,000 people. It's got a full ventilation system. It's even got its own security doors. It's an amazing thing. And it's still almost as good as the day it was built. And then more recently, there's this one in Pompeii, underneath the city of Pompeii, where they've just discovered, and this is only in the last few years, that the drainage system under Pompeii is still in a serviceable condition, and with just a minimal amount of maintenance, is being brought back into full service. So they've refurbished half a kilometre, and they're working on another half a kilometre right now. So those are ancient ones. Let's come a bit further up to date. Let's have a look at this country in particular. Since we invented tunnelling, there you go. Get that out of the way. Here are a few examples. Dudley Canal Tunnel, built in 1792, still in constant use. It's used every day by tourists. It's been refurbished a bit, but it is in constant use. This is probably the world's oldest road tunnel. Built the Beemster Tunnel, 1832. You might remember this was in the news a few years back when there was a landslide here and buried a couple of cars and killed a few people. Wasn't being properly maintained, but it's still in use. On the right here, the famous Bazalgette London Interceptor Sewers, built 1865 by Joseph Bazalgette. Even though we've got Thames Tideway is only a supplement to this system. It doesn't replace it. This will still go on in use for another 150 years, hopefully. Famous box tunnel here. This was built by Isambard Kingdom Brunel on the GWR, the God's Wonderful Railway. In 1841, it was in its day the world's longest tunnel, and it maintained that for an awful long time. It's actually pretty big. It was built for broad gauge. And legend has it that on Brunel's birthday, the sun shines down the tunnel. Whether you believe he made that deliberate or not, I don't know. Another more close to home here is Baker Street Station, 1863, the world's oldest underground railway station. And it's still exactly as it was in 1863, and worth a visit, really, and have a good poke around the place. There's quite a lot of posters pinned up around it, so I'll tell you what the history of the place. These are some old UK tunnels that have been converted to other uses. The Woodhead tunnels up in Derbyshire, built in 1852, and this one here now carries power. Those are the original tunnels built in 1852. This was built in the 1950s there, and now that one there is now carrying cables, and they're thinking about using these for cycleways. So that's the Woodhead tunnels up in Derbyshire. Keep an eye out for that. That'll be a big contract when that comes out. And it's likely to come out in the next few years. The famous Brunel Thames Tunnel, probably the world's most famous tunnel, on what was the East London line, now part of the London Overground. The world's first shield-driven tunnel. An amazing thing. Built in 1843. As a pedestrian, it was originally for horses and carts, but they ran out of money, so it ended up just being a pedestrian, and they used it for as a fairground as well. But it was converted to a railway in 1884, and it was completely refurbished in 1998. Be a bit more about that later. This is the Strood and Hyam canal, originally a canal tunnel, converted to a railway in 1845. It's actually got this shape here because it used to carry masted barges through there, Thames barges with the masts. So it has quite a pointy shape. The canal is actually down here somewhere. So half of this tunnel has been filled in and a railway put through. It was fully refurbished in 2005. Again, closer to home, the Kingsway Tunnel and Strand Underpass. Originally a tramway in 1906, closed in 1952, and then it was reopened as a road It also carries cables. It was refurbished in 2008, and there was a fire in 2015 in the cable part of the tunnel you might have heard about. On the right here, Hindle Station. This is part of the Liverpool Overground, which actually goes underground, but this is the terminal station to the old Liverpool Overground, which was converted into an underground garage, a car repair shop in 1977. Unfortunately, it collapsed and was abandoned in 2012. A little bit more about that later. This one, I don't know what the status of this is. This was a report in Tunnel Talk in 2018, converting this tunnel into a vehicle test centre. I don't know what status that's in at the moment. Maybe because I'm a little bit out of the business, having retired, so I don't really follow whether these contracts are coming up. But certainly, it looks like it's a goer, that one. Worth keeping an eye on. This one I found just the other day on the internet. This is quite an interesting one. This is the first railway tunnel ever built in Canada, in Brockville, which is about halfway between Toronto and Ontario. Toronto in Ontario, halfway between Toronto and Montreal. Ottawa just to the north. So this was an old railway tunnel, and it's been converted into a pedestrian tunnel. I don't know if you've been to Ontario, but in the winter they have a lot of underground walkways. Obviously the weather gets pretty grim there. So this is about how long is it? Half a kilometre long. It goes right under the city centre, so it's pretty handy as a walkway. There are ways up to the surface all the way along here, but you can see they've made it quite pleasant inside with a light show. It's fully air conditioned and it's heated in winter. So this gives you an idea of what you can do with some of these abandoned tunnels with a bit of imagination. Going back to that Hindle tunnel, why was it abandoned? Well, in 2012, well, it collapsed because it wasn't being maintained. And you can see all these rather expensive cars. This garage specialised in repairing high-end cars, so that's a Range Rover under there. There are a few Jags buried under there as well. So unfortunately, they were lucky people weren't killed. People were actually working down there when it actually collapsed. And that collapse, I went to see it, the collapse actually chimneys almost to the surface. In fact, if you look right up into the top with a strong torch, you can actually see the foundations of the terraced house above. They were really lucky in that house too. In the end, this was just basically infilled with concrete and abandoned, which is a pity, really. It's still there. It's still possible that it could be refurbished, and they are talking about refurbishing the old underground line as a new metro, as part of a new metro for Liverpool. So let's have a look at how these tunnels were built. The older tunnels were all built using, almost, if they could get away with it, no support at all. Just dig the hole. Or some very minimal type of support. More commonly, stone masonry or brick, sometimes terracotta, which was used mostly for the finishings. Brick and terracotta. Mortar, just plain mortar, often used. Often Roman mortar or lime mortar. Certainly the brick mortar was often lime mortar or Roman mortar. Unreinforced concrete came along late in the 19th century. And of course, most of London Underground is constructed with this stuff, grey cast iron, not spheroidal graphite, SGI. It's mostly grey, which is much more brittle than SGI. Or this traditional one, steel ribs and lagging, sometimes referred to as colliery arches. We'll have a look at that later. So these could be used in a combination, but often this timber support is often left behind And when they put the brick arch in, they can't. It's very difficult to take the timbering down to get the brick in. So quite often they left it in there and just packed stone and rubble around it. And now that this stuff is rotted away, there's all the weight comes on the brick, and that's probably one of the reasons why the Dingle tunnel collapsed. No waterproofing hardly usually. Although the Brunel Thames tunnel did have quite a complicated water drainage, back of lining drainage system. Very basic drainage, the design life unknown, but how long do these last? Some of them are still being used 150 years later. Almost no maintenance done on any of these tunnels, and what has been done is very poorly recorded up until the last decade or so. Contrast that with modern tunnels. Well, what we got in our toolbox? We got rock bolts, the magic sprayed concrete, shotcrete, precast steel reinforced concrete segments. That's probably the number one method of lining tunnels these days. Spheroidal graphite iron, SGI, knockout. We don't use cast iron anymore. Again, often in combination, often with some external stabilization, much more sophisticated waterproofing, drainage, fire protection, usually designed for a minimum of 120 years in civil engineering. Often requiring only basic maintenance. They're built pretty well in the first place. But sometimes they do employ some of the old methods, like steel ribs and lagging as temporary support. Still used. Although, particularly in America, actually, oddly enough. So, in terms of maintenance and inspection, most of the utilities have their own methods of doing it. And some time ago, the Syria organization, along with these good people, some of them have gone now, Metronet have gone, but certainly HSE, London Underground, tube lines have gone, Network Rail is still there. They put together from their own methodologies this compendium, and it's pretty good. It's pretty good. I think W.S. Atkins actually did the donkey work on it. But it presented good practice, guides for routine management, assessments, knowledge search sharing. You can download this as a PDF. It's quite a thick tome. It's about an inch thick. Or you can have a nice paperback copy for your shelf from this website. I recommend that if you're going to get into this part of the profession, to have that one on your shelf or on your computer. A typical maintenance inspection report. This is a typical Network Rail version of it. It's pretty comprehensive actually, and they all follow more or less the same pattern. Obviously, a photograph of the key things like the portal, where it actually is, the location, and its actual each of these structures, just like the bridges. There it is the number of that tunnel, so you can look it up. Here is a visual report with a sort of a scorecard here. Here is a sort of a graphical version. There's a sort of developed plan view where you've got the crown and the side walls and the invert. It'll also be supplemented with lots of photographs of really bad bits, and there are plenty of them in these tunnels, believe me. I mean, here we can see probably there's a crack in the brickwork here, and this is stalagmites and so on being formed with seepage water. More recently, these visual inspections are supplemented by things like radar scans, LiDAR, and laser. You'll see that increasingly, and these are getting so detailed now that they're almost like photographs. You can get measurements to less than 1 millimeter now with these. Profile surveys, They used to use, in the old days, what they used to call a trammel, which they just push in there and just like a frame, and they just measure offsets from it. But now it's done with the total stations, the other lights. Obviously, you need to know what the condition of the lining is, so you do some core drilling through the brick lining. See what the how many brick thick it is. You know, has it really got 3, 4, 5 courses of brick? And more particularly, what's behind the lining? Quite often, there's nothing behind the lining. It's just a void, or it's just rotten timber, or it's just rubble. Very useful drone surveys, mostly for getting to places where it's too dangerous to get to, particularly ventilation shafts. A lot of these tunnels were built by sinking shafts at regular intervals and then tunneling out on either side of the tunnel. So these shafts still exist. A lot of them. There are a lot of them. And a lot of them are either hidden or concealed or sealed up, and most of them in a pretty dire condition. So having got your tunnel, let's look at the most basic thing on maintenance. Well, obviously keeping it clean. I think that's the Greenwich Foot tunnel, and all you need to do in there, because of the people walking on there, you've got to keep it reasonably clean. It's a bit like a gent's toilet, I suppose, but smells a bit like one too. But all you do is water jet it every now and again. Highway tunnels, they're maintained more regularly using this mechanical brushing and washing system, mainly to keep the luminosity of the tunnel up to standard. Because obviously, it gets more dirty, it gets more difficult to distance. This is a new sort of idea with the railway tunnels. This is soot. This is 100 years of soot accumulation, and of course it covers up the condition. You don't know what the condition of the brick is, so you have to actually scabble the soot off. The soot can be a couple of inches thick, and the problem with that is it's carcinogenic. So this machine is actually a great big Dyson vacuum cleaner as well, because you have to be careful that if you are cleaning a tunnel, the material that's being taken off and the water runoff can well be contaminated, and you could get into deep trouble if you chuck it into a water course. Repairs, well, let's look at the minor repairs. Just cutting out the brick. So if you've got more than one layer of brick, well, yeah, we can cut out a layer and the tunnel's not particularly compromised. You do it in windows, so you at least you do that, and then you infill that and then do that and so on. You wouldn't knock out an entire strip of a course of brick. You destabilize that inner lining. Repointing, just simply repointing, is probably good enough. That's done an awful lot on Network Rail. If you cut out the brickwork, well, you can infill it with cement mortar, or even concrete, or fibre reinforced concrete's the main flavour of the year. This fibre reinforcement, very good. A problem with this can be shrinkage, so you want a low shrinkage grout, and the fibres definitely help there. Or if you're feeling really flush with money, you could actually put new brickwork in there. Certainly, if it's in an area where it's visual, there are people walking along there. A bit cruder than that may be internal strengthening. These are ribs and lagging, and then it's being shotcreted. But it's an internal sublocal. It's only over a short distance. It can be they can get in and do that pretty quick. Grouting, obvious as these linings don't have anything behind them, voids or just rubble. So you have to inject grout through the lining. This is actually on the Jubilee line south of Bond Street. And that was only constructed in the 1970s. And what would have been happening was that the lining had been leaking, and the material behind the lining, which was a bit silty and sandy, it wasn't London clay, was seeping into the tunnel and leaving big voids behind. So that was all grouted up south of Bond Street. Sobs, they called it. There was another job north of Bond Street they called Knobs, which we'll look at. So why would you bother to refurbish these tunnels? It sounds, but sometimes you've got to convince your client, or an insurer. Well, obviously, you want to extend its useful life. That seems blindingly obvious. Yeah? Health and safety often. A lot of these tunnels can get quite dangerous. Certainly that Strudenheim tunnel was getting pretty dangerous. What was happening was the chalk was delaminating, was actually falling off in slabs. A lot of brick tunnels, the inner brick lining delaminates from the rest of the lining and becomes very unstable. You may need to modify the tunnel for some reason. Often you may need to install new services or something like that, and you need to fit those in. So the tunnel might require modifications. London Underground do an awful lot of that. Change of use. Well, we've already seen change of use. Changing from a pedestrian to a railway and then back to a cycleway. So that is becoming flavour of the month, this. You're going to see an awful lot of this, particularly cycleways. Old tunnels being converted to pedestrian and cycleways and for other uses. This is also becoming big business and will become very big business, required enlargement of the tunnels. We'll have a look at a couple of examples of that. Why would you enlarge the tunnel? Well, if you're going to electrify the tunnel with overhead lines, you need space. In the soffit, there may not be any. So you've got to enlarge the tunnel. Or it could be a combination of any of those. So how would you go about doing it? Well, strengthening, under the heading of strengthening, well, fill the void behind the lining, best to fill it up. And the way to do that's to grout it. You could put internal support inside the tunnel. The only problem is that reduces the gauge of the tunnel. So if all your support's on the inside, you may not be able to fit the train or the traffic through there. Ground anchoring. Some big examples of that have happened. Severn Tunnel particularly. A huge contract for ground anchoring before they could reopen that tunnel. And underpinning, strangely enough, you wouldn't think would do that with a tunnel, but it is done. And we'll have a look at some examples. Relining, well, you've got a pretty good arsenal these days for relining. You can use spray concrete. This is a specially designed carriage where basically the guys applying the shotcrete are protected from the live railway alongside it. When they're actually working, the ends are screened off as well. And there's you can see the bag is inflated at the top, and these flaps come, so the thing is sealed off. So, and the guys are working in safety. So that's being tested on Network Rail now. There's also cast concrete, steel ribs and lagging, as we've seen before, often with sprayed or cast concrete. And tunnel segments. Now, segments can be, these days, precast concrete, steel, or SGI. Invert replacement or lowering. Instead of cutting out the roof of the tunnel, you might be able to get away with just lowering the invert of the tunnel. And obviously just completely reprofiling and relining and enlarging. That is where the big money is. Some big contracts being done recently in that. And then, again, with that, Germany is going to lead the way in this. We'll have a look later why. So void filling and grouting. Well, as I said, behind these brick linings, the brick lining is a bit like a cheap suit. It fits where it touches. So you've got these voids. These could be filled with rubble or rotten timber. So when you grout, you drill the holes in the lining at regular intervals, and you start the grouting from the bottom and progress upwards, bleeding the grout as you go and sealing these as you go until you finally get to the top and the grout bleeds out to the top. So you've got to do this in a fairly controlled sequence, not just circumferentially, but laterally as well. And of course, the drill rigs can be pretty big. So it can be a bit of a problem fitting this into a tunnel, especially an old confined one. Especially when you've got the HSE on your back and want all this caging around the drill as well. Internal support with steel ribs, that can be done just to temporarily stabilize the lining. That's the steel ribs, the lagging behind it there, timber lagging. You can see the brick, or masonry, I think. Oh, it's brick. Behind the lagging. Steel ribs, tie bars. You know, even here they've got crown bars and horse heads and all that good stuff. And you can see here that the tunnel is in a pretty bad condition, just a little bit further along. So that was Stand Edge Canal Tunnel, completely refurbished about 15, 20 years ago. In its day, the longest canal tunnel in the world. It was a pretty impressive undertaking for the end of the 18th century, built in the 1790s. This one here, this is a more modern version of what's being proposed for this Queensbury cycleway, using steel arches as a permanent support on the inside. Not too worried about losing gauge, you see, for cycles. So we can do that. If it was a railway tunnel, that might not be possible. This is a new idea. I want you to pay particular attention to this because this is my pension. This is called ram arch. It's now the method of choice for Network Rail for doing internal strengthening. These are steel mesh panels which have been deformed, so you can see it has a sort of a lattice girder incorporated into the mesh. And they come in 2 meter long by 1.3 meter wide panels, and you just simply bolt them together at these points here, and you make an arch. The arch arrives on a pallet, so one pallet, one arch. It's assembled on a cradle on the ground. It's lifted up into position into the roof, and it's fixed in place and overlapped. Each arch is overlapped by 0.3 meters, 300 millimeters. So for each arch is actually 1 meter long. Okay, and it's fixed at the bottom. It's anchored to the side wall in the bottom, mainly to prevent further delamination of the brick lining. But later, you can just apply shotcrete, and you've got yourself a reinforced concrete lining. There's a video here now, which will show you how it was actually built. This was White Ball Tunnel. It was the first one that was built with this material back in 2011. So far, there have been about nearly 24 jobs done with it. And you can see how quick it is. Now, the Network Rail were looking, this was developed specifically for Network Rail at their request. They wanted a system that they could get in and stabilize a tunnel in engineering hours or a weekend possession. Get in, get out. And they also wanted a system which was safe for the men to operate in the tunnels. Now you see they're assembling the arch standing on the ground. Yeah? So all the bolting and attachments are done standing on the ground. These are stiffening and connecting ribs, rebars, which are again attached on the ground. So as they attach each panel at the bottom, it's pushed over the top of the cradle and lifted up into the soffit. Once it's up in the soffit, the guys go up there and fix it in place in a cradle. the more modern, the more up-to-date version of this, we have expansion joints, and the arch is expanded up into the soffit. Just have a quick look at it again, just to get the idea. It is pretty quick. It's not that quick, but you know, it's you can do an arch in about 10 to 15 minutes. So you're advancing a metre every. You can do 4, 5, 6 meters in an hour. Right. And you can see down the other end of the tunnel, you might have seen there was another complete operation going on as well at the same time. That's White Ball Tunnel. Again, it's another Brunel tunnel, so it's pretty big. It's down in the West Country. And again, built in 1850-ish. Never been maintained until now. And in fact, there is a contract out, or I don't know whether they're doing it now, to actually put the shotcrete in. This is one more recently done with Ram Arch. This is Queensbury Railway Tunnel. You might have read about this. There's been a bit of controversy about this tunnel. It's over 2 kilometres long, abandoned in 1963. There were some big collapses in. That's one of them. I think it was 2012, not 2014. And temporary works on this tunnel began in 2018. And they were finished around about Christmas last year, using Ram Arch. This time the Ram Arch is taken right down the side walls and is founded on the base. Yep. And there's quite a few sections of this done. So the question now is this going to be, it's being considered for conversion to a cycleway. There's a huge lobby, or huge support for this, but it's not going to be cheap to convert this tunnel. Unfortunately, it gets flooded, and also the landowner is holding out for a lot of money. But I think it will get done eventually. It's too good an opportunity to miss, and they've spent a lot of money stabilising it to just abandon it now. So the other method is ground anchoring. The Severn Tunnel, as I mentioned, constructed in 1886 by Hawksworth, and refurbished in 2019, ready for the electrification, which is now in place to Cardiff. So massive program of anchoring went on in there. A bit similar to this one here. This is Abbott's Cliff Tunnel down on the south coast, near Dover, done in chalk. So this is a similar hole pattern to the Abbott's Cliff Tunnel. I think designed by Donaldson's Covey. This one, Stand Edge Tunnel again. We saw the steel ribs lining. This is where it was anchored in the roof with steel mesh, long rock bolts. Now I mentioned underpinning. You wouldn't think a tunnel would be underpinned, but they do it. These are 3 big contracts that were done. On the left, Netherton Canal Tunnel. That's up in the Midlands near Dudley. Big tunnel, one of the biggest canal tunnels in the country. It had a towpath on either side, and it's quite deep underground. It's several hundred meters below the surface, and in the centre of the tunnel, in the centre of the alignment, the tunnel's about a mile or so long. The lining was becoming heavily deformed with vertical stress. So internally, there was a ram arch and shotcrete lining, and that was founded on horizontal reinforced concrete beams, which were supported by mini piles with lateral anchors just to stop the things kicking in. A simpler version of that, simply because there's more room. This is stand edge railway tunnel. That was designed by OTB. This one was designed by Donaldson's. Where they used vertical piles. They could get the piling rig in to do vertical piles. You couldn't do it here, so these had to be raking piles, hence the need for these anchors, but vertical piles here. Exactly the same idea. This one is that Struden-Higham railway tunnel. Remember, that's the one with the masted barges that went through. Quite a long section of this had to be underpinned with a new concrete arch above to stabilize it. These are pretty big jobs, these. But nothing recent. Well, that's the most recent one, done in 2015, 2005, 2009. That one there, stand edge, is likely to be looked at again as part of this Transpennine link. The tunnel still is unstable. So that'll have to be revisited. It'll probably have to be enlarged as well for electrification. Sprayed concrete, good old shotcrete. What can I say? It's pretty extensively used now for tunnel refurb. Just simply either just spray it on the brick just to bind it together. This is Sugarloaf Tunnel down in South Wales near Abergavenny, and you can see the shotcrete has been formed into ribs. Yeah. There's quite a paper written about that. There was a presentation given in here when that was built back in the 1990s. Netherton we just mentioned, that's Netherton in progress. This is a barge underneath here with a flat back top on it, and then gave a working space to build the reinforced concrete lining. White Ball, that's the ram arch there, and this is it being shotcreted. That's the sort of finish you can get. You end up with a reinforced concrete tunnel lining. This is quite an interesting one I did years ago, which I thought I'd put in, very interesting. This is Byera Hill in St Vincent. Not a very big tunnel, but very, very interesting. Built in 1811 by plantation slaves. No support whatsoever in it, but starting to show its age, and heavily used by locals. Actually a main thoroughfare, actually. And this was refurbished in shotcrete by Shotcrete Services Limited, British. And the arch, that is actually done in shotcrete, believe it or not. It's not cast concrete, that is shotcrete. So it shows you what you can do with shotcrete. They did a few other tunnels like that in the Caribbean. Now this is the famous one. I was involved in the early stages of this. It's the Brunel Tunnel, the famous Mark Brunel Tunnel, Isambard's father, Mark Brunel. Isambard finished it off, but Mark came up with the idea in the first place in 1825. He devised the world's first tunnelling shield. There's been a lot of presentations about this. You can read up about it. There are books written on it. Basically, it was getting in a terrible condition. The old terracotta lining was completely stripped out, as was the track bed. And the internal finishings were done in cast concrete. And the cast concrete had to match the original finishes done in terracotta and plaster. So you can imagine what that cost. It cost a fortune. The contractor and the consultant walked away with big smiles on their face. But you can see how intricate the shuttering was pretty amazing for this. And then as soon as they'd finished it, they had a dinner in there, and then they covered it up with all the cables and signalling, and then you can't see it anymore. I think the Brunel Society have a walkthrough every year. Might be interesting. If you go to Wapping Station and peer down into the gloom, you can see a little bit of it. Unfortunately, not visible in all its glory, and you'll never see that again. When it was finished, it was absolutely magnificent. Oh, some sprayed concrete was used on that job, but not much. I think the sprayed concrete had fibres in it. Beckert fibres, Dramix, of course, just to keep him happy. So this is where steel ribs and lagging is used to replace the lining, not as an internal support. The lining was actually cut out and replaced with steel ribs, and then shotcreted in between the steel ribs and over the top of the steel ribs. I think they cast the sides. I'm not absolutely sure about that. It may be shotcrete that's just been rendered. But a nice job. This is up near Burnley, it's between Burnley and Todmorden up in Lancashire, the home tunnel. Done a few years ago. Designer, I think, was Donaldson's again. Oh, in between the ribs, they used ram arch because they were worried about bits falling out. Here's some interesting jobs. There's one man in the audience recognises these. Blissworth Canal Tunnel. Here they replaced the linings with segmental, old-fashioned segmental tubbing segments. Yeah. There was a bit of a vogue for doing this at one time with the canals. There was up in Birmingham, they did some of these. This is a very interesting job here, and the man who did this is sitting. There he is, white-haired man up there. Yeah, this is actually on the Northern Line, so at Old Street. The original grey cast iron was rotting away because water was acidic water was seeping through the lining and rotting it away. So the lining was replaced by stainless steel segments, stainless steel segments. Imagine what that cost. But the most interesting thing about this is it was done on with a mobile shield, behind a mobile shield, so the train traffic actually kept going. So in engineering hours and at weekends, they replaced the lining, but the traffic through the tunnel was not interrupted during the week. That was a world's first, that. This job more recently on the Jubilee line between Bond Street and Baker Street, although it was only constructed in 1970s, it had to be relined in 2015. The original linings here were concrete segmental linings, which were expanded linings, and they didn't really work in the ground conditions there, which is not London clay. They were starting to deform very badly. So what was done, this was cooked up when I was at OTB, but it was later finished off by tube lines. Here we see temporary rib support holding the segments in place. And here we see the segments being removed, and here we see the new cast iron linings, SGI linings, being installed, all using an engineering train with a lifting jack. Pretty complicated job, but it was very successful. Got some very good write-ups, that job. I can see it being used again. Invert replacement, as I mentioned. So instead of trying to increase the height of the soffit, you can simply chop out the invert and install a thinner track slab. So that was basically to get more headroom for the railway. This is Chorley Valley up in Lancashire. Or again at Netherton, same problem. But here, what was happening was they were losing gauge because the invert was being forced up by ground pressure. They had what's called bottom heave. That's an old term for you. You look it up, bottom heave. And what they did was they took out the brick and puddle clay linings and replaced them with mass concrete. Done in 1983, a bit before the ram arch stuff was done. Coming to the end now, reprofiling and enlarging. Timing. Oh, good timing. Reprofiling and enlarging, this is going to be the big money. This is going to be the big money in future, yeah? You're going to see a lot of this. Mainly because if you want to electrify railways, yeah, or you want to increase the gauge for continental loading gauges for roads and so on, you've got to make the tunnels bigger. It's even in America. I mean, here this Berry Street tunnel in Pittsburgh in America, enlarged in a very old tunnel, 1865, enlarged in 1997, and it was done using, dare I say it, NATM, NATM. I've got to say that in dulcet tones in this august institution. But it was enlarged using NATM principles, assuming that this was basically a pilot tunnel. So it was done with lattice girders, rock bolts, yeah, shotcrete, done in 1997 by the Dr. Sarr company. You can see the brick lining being ripped out here, and the lattice girders and shotcrete going in straight behind it. So that was done in 1997. In this country, this one here, this most recent one, this is my last job that I did before I retired. Farnworth Railway Tunnel up in the north of England near Bolton, built in 1838 by Hawkesworth. This is a twin track, originally a twin track brick and masonry arch tunnel on this side. It was converted from twin track to single track when steam trains started to have big smokestacks. When the steam trains got bigger in the 1860s, they had to use that as single track, so it was single track railway for a long time until they built this single track tunnel alongside it. I think it was built right about 1910-ish, something like that. What Network Rail wanted to do was enlarge the return this to twin track and enlarged so that they could put electrification through and a double track. So this was done with a shield, and it was the biggest, if you class a shield as a TBM, it was the biggest TBM job ever done in this country. It's about 11 metre diameter. So that's about the size of HS2. So the problem was that these two tunnels are only separated by a metre or so. This tunnel here was in pretty bad condition as it was, so this had to be strengthened before this could begin. It was quite a job done by Murphy's. It's not very long, it's only 200 odd metres long, but it goes right underneath the A666 dual carriageway, one of the main roads into Manchester, nicknamed the Devil's Highway for obvious reasons. The subsidence on that highway from this job here was 300 millimetres. It was that close to the railway. It was just underneath the road. And the subsidence was unavoidable, and it was 300 millimetres. Murphy's, although we were thinking of a million ways of avoiding this subsidence, compensation grouting, strengthening the road, etc., putting temporary bridge across. Murphy's came up with a perfect solution. They just sent a crew out every night and resurfaced the road. It worked. The only way you could see it was that the crash barrier gradually started to sag. But they've even repaired that now, so you can't see it. There's half a metre of tarmac under there, though. Anyway, interesting job. Actually, this was presented here by the young members, by a young member in our group, Owen Murphy, a couple of years ago. I think the lecture's still on the system somewhere. Yeah, you got to mention the Germans, I suppose. Of course, they're in on the act, and they've mechanised it. Good old Heron Connect, he's in there. This is a tunnel enlargement shield. Yeah, so keep the trains running, and basically a fully mechanised shield and TBM that rips out the lining, enlarges the tunnel, and then shotcretes it. Job done. That's going to be the future. It really is. Finally, this. It's I'm a bit disappointed with this, because this is a really excellent report that was written by a guy called Jared Quigg, who was a BTS young member when he wrote this report. It's one of the best reports on the subject I've ever seen. And it reviews all the methods used to enlarge tunnels with case histories and so on. The idea being that this was going to be a part of this report done by TRL, which was going to be a decision-making tool for Network Rail on what they're going to do about enlarging railway tunnels. It was done in a couple of years ago so far, and it's never been taken up, and I don't know why. Really disappointing. Anyway, if anybody's interested in this document, again, it's a fairly meaty tome. It's at least half an inch or an inch thick, and it's got lots and lots of case histories, lots of the ones that I've just talked about. So if you're interested in that, just let me know, and I can let you have a copy, or try and get in touch with Gerald. Or I suppose Jared works for Covies now, I think. So they probably have copies of it. Okay, so that's the latest thing, and believe me, that's going to be the future. So having said that, we're left with a lot of questions. So while you ponder questions, you can figure out who these hairy people are. Some of them are mentioned around this room. None of them are quite as old as me, but there you go. Okay, thank you.
Yeah, shall we thank Dave with a round of applause?
How's that for Tom?
We might take a few questions from the floor.
Hi, thanks for the presentation. Just a question in regards to tunnel maintenance, repair, improvement, at least here in the UK. I'm from Australia, as you can probably tell by the accent. How much is given to durability, particularly when you're using reinforcement steel in shotcrete, and you're wanting 120-year design lives? I know there's a lot of consideration given to the structural aspect, but what about durability of the materials being used?
That's a good question, that. It depends on who your client is. Network Rail don't always require 120 years. It may not even be possible, because there's not enough space, often, to get the required cover to steel, for instance. You do aim for it as long as possible. And if you can do 120 years, then do 120 years. I would think if it's a lining replacement, where you're chopping out the old lining and putting a new one, certainly the Farnworth Tunnel, that was 120 years. Yeah, but where you're doing patching up and just general maintenance or repairs, well, they may only be interested in extending the life of the tunnel another 20 years and then do it again. Because remember, you close these tunnels off, and it's big money involved. I think certainly London Underground, the old street replacement, that'll be better than 120 years. I think when the London Clares eroded down to that level, that bit of tunnel will still be there. You know, there'll be archaeologists wondering, what the hell is this? Right, John? Yeah? So it's horses for courses, but certainly if you're going to replace the linings, yeah, 120 years.
There's no question here.
Here we go.
Thank you, David. John Austin from Motivey Engineering. Sorry I missed the very beginning of your presentation, Dave, but I had to get a police escort because I'm sponsoring the bar tonight, and just wanted to make sure we got here in time. Thanks ever so much for the presentation, David. I don't know if you touched on it at the very beginning, but obviously sometimes these tunnels have very limited clearances and with the deformed shapes. Is there basically a mechanism for trimming back the lining to then install the secondary lining?
Yeah, that's often done. There's an interesting one, is right up in Tunnels and Tunnelling a year or so ago, Springs Tunnel. They thought that there was 5 courses of brick. So they thought, oh, well, we can chop out 2 courses and get away with it. And maybe chop out 2 courses, replace 1 course with shotcrete. But when they chopped out the first course, they found that's all there was. So it was a bit of a panic then. So that's the problem. Although when you look at the tunnel portal, brick line tunnel portal, it may look like there are 5 or 6 courses, but that doesn't mean to say that's the case all the way along. Another problem you've got with these older tunnels is that the inner course, the innermost course, is the best brick. It's normally engineering quality brick, whereas the brick behind it is normally rubbish. So you take the good stuff off the front, and the stuff behind it is just too weak. So if you're going to do tunnel trimming, and it is done, no doubt about it, it's done. You've got to do a lot of investigation, a lot of intrusive investigation before you attempt that. Take lots of cores, test, first of all, find out how many bricks there are, courses of brick, find out what's behind the brick, and find out what the quality of the brick is. Yeah.
Just one more question. Back.
Awful lights, aren't they?
Excellent. Thank you again for that really good presentation. I was very interested to see the cages that you talked about being installed inside the tunnel lining. I was very interested to see what were the cages anchored into. Was that just the brick rings, or was that?
Yeah, that's another good question. The one that you saw in the video, whilst it was a Brunel tunnel, so the inner course of brick was pretty good. Brunel had a particular way of testing bricks. He used to take one out of every couple of hundred, put it in a bucket of water for a couple of days, and then hit it with a hammer. And if it broke, then he'd reject the whole batch. But he only ever did that with the final course of brick. So that inner course of brick at Whiteball was good engineering brick. The only problem was that it had become delaminated from the brick layers behind. So it was becoming delaminated and loosened. And because they were running high-speed trains, 125-mile-an-hour trains through there, the pressure waves were sucking the brick away, and it was getting worse. So they had to reduce the line speed down to about 30 miles an hour through that tunnel, which affected the service. So the initial thing was to get a mesh up there quickly, which would hold that inner lining brick in place. So it was really only supporting, in its temporary condition, that inner lining. Now what they've done is they've extended the reinforcement down to the invert, and they've shotcreted. So now they've got an inner reinforced concrete lining. They could get away with that on the Whiteball tunnel because it was a Brunel tunnel. Brunel over-designed tunnels. He built them for his broad gauge, trains with the big high smokestacks. So the tunnels tend to be much bigger than Stevenson's or Hawksworth tunnels or Locke's tunnels that came later. So that was what you saw there. So just getting to your question, those arches could be anchored into the brick itself. Yeah? Now we're looking at other tunnels, particularly that Queensbury tunnel, and another one that's going to happen this year called Clay Cross. The brick is in much worse condition, particularly the inner brick, so you can't anchor into it safely. You start drilling into that, you'll bring it down. So the latest version of that system, ram arch, the arches are anchored at the bottom in the footings, and then each of the panels are expanded. So each of the panels are pushed apart so that the arch pushes itself up into the soffit. Another good reason for that is these tunnels are no longer have an even profile. And that is a big problem with these tunnels. They don't just deform uniformly, they bend all shapes, they really do. And they bulge and they crack. So the ram arch has a sort of flexibility built into it. It's flexible until it's put in place, and then additional steel rebars are put in and tied in, which stiffen it up. Then once you shotcrete it, then it becomes a fully stiffened lining. So it's an evolving system. We have recently had to modify it to make it even thinner because the standard thick width is, the standard height of the arch is about 160 millimeters. Network Rail have asked us to reduce that to 100 millimeters simply because some of these tunnels don't have any clearance at all left in them. And of course, if you reduce the height of the steel arch, it loses its moment capacity and it will bend. So you've really got to get the stuff in there and then shotcrete it as quickly as possible.
Thanks for the presentation. It's a good question. You've included quite a lot of case histories, and I presume in order to repair and improve tunnels, you need quite a bit of, I think, information, detailed drawings. How easy was it to come by these drawings, and do you see anything that we could learn from the process that you had to do to put this together for the new for say Crossrail and HS2 in terms of actually making things easier for the future?
Yeah, that's another good question. It's different. Designing tunnel refurbishment is a bit different from designing a tunnel from scratch, in that you're often having to do a lot of design changes along the line of the tunnel, because the tunnel profile is changing and the tunnel conditions are changing. It's only really when you're doing a complete lining replacement you can get away with a standard set of drawings, such as at Farnworth, where the design was just a single segment ring. More often than not, you have to say from this chainage to that chainage, you're going to put in 100 mil of shotcrete with some mesh reinforcement. From that chainage to that chainage, you have to use ram arch, and that chainage to that chainage, well, you've got to trim the brick back and put in steel ribs. At Stand Edge, the tunnel was in such a bad condition, the single bore tunnel was in such a bad condition over a 15-meter length that ram arch would not work. We had to use heavy steel ribs, and to do that we had to cut out slots in the brick lining and insert the steel rib into the slot and then shotcrete the whole thing in. So it's you've got to have a bit of a toolbox in some of these cases, unless, as I say, you're going to replace the entire lining. So if you do that, you can go at it just as if it's just a pilot tunnel for a new tunnel.
Any further questions?
We've done that. Oh, the names have come up by now.
There's one more question in the front row.
Well, thank you for the presentation. You briefly mentioned drainage works, but I don't think you gave very detailed examples of that. Is it because maybe it's not used, not very economical, not time efficient, or just wondering?
Well, they were less picky in those days. If the tunnel dripped, it dripped. You know, they just let it drip. The most amazing one was the first one, the Brunel tunnel, the original Thames tunnel. You know, one of the more sophisticated drainage systems. The brick lining had channels in it, circumferential channels, and then Brunel laid terracotta roofing tiles over the channels to create a water drainage system, and then he plastered over the top of that, rendered over the top of that. And those drains went into a collector drain along the toes of the tunnels, and then down to the low point where there was a sump. I'm not quite sure how we got the water out in the old days. We didn't have a steam engine in those days. It became a bit of a problem in the refurb job, because once the tiles came off, it was a bit hit and miss. It turned out that he'd done this on a bit of a hit and miss approach. Sometimes he built up the bricks to make the channels. Sometimes he chiseled them out, because the build quality wasn't that wonderful. It looked great, you know, once he tiled it and rendered it, but the actual build quality behind it. There's some quite interesting stories about how that refurbishment was done and why it was done. But that was the most sophisticated drainage system I've ever seen in an old tunnel. More often than not, they just simply drain behind the linings, and you might see weep holes drilled or little ducts left at the toe level. So the water that seeps in that void behind the lining just seeps out to the bottom. Often these tunnels don't have inverts either. So the water just wells up. The Strudenheim tunnel, the one that was converted from a canal, the reason it was refurbished, one reason was that the water used to come up from below and flood the tunnel when it rained pretty heavily. The Severn tunnel, even more interesting. The Severn tunnel had, or still probably has, a pretty bad leakage problem. One is saline water comes down from above and rots the signalling and the track away, and fresh water comes up from below from a spring that's underneath the main tunnel. So Hawksworth, when he designed the tunnel, he put a drainage tunnel directly below the Severn. Below the Severn tunnel there is another tunnel which is to drain the upwelling spring water. And that spring water is some of the most pure water in the country, and it's used for a brewery in Bristol, and it used to be used for a paper mill as well. I think it still is, actually. It's called the Great Spring. Again, worth reading up about. Yeah. So it's a varied lot, it really is. Some have drainage, some don't. Big leakage problem you'll find on London Underground. If you wander around London Underground, you can see they've got these sausage-shaped things on the ground to soak it up. They call it Operation Sponge. So, yeah, water seepage, water leakage and drainage, big problem.
There's one more question in the back.
Oh, good, the bar calls.
Young Lou from Arup, thanks very much for your presentation. You mentioned a few innovations there. You covered your Ramarch, like the drones, the enlargement of tunnels, but you also mentioned the guidance from C671, which I agree is excellent guidance. However, that's over 10 years old now. Is there a plan to upgrade that, or is there a need to upgrade that? Maybe for the BTS.
Sorry, I didn't catch that last bit.
Is there a plan to upgrade the C671 to a new edition at all? Perhaps being led by the BTS or something like that? Or
Well, I think it should be revised. I don't know. I mean, Jared did that. That was done when he was a student at Warwick, and he worked for Donaldson's at the time. I don't know whether Covey would be interested in taking up. I think it's worth taking up again, and I think an outfit like Arabs could well champion something like that. Because it's going to become. We're going to have to look at it sooner or later as formally, put a formal specification together for how it's done. At the moment, it's pretty ad hoc. The danger is, you see, you get into these. Every time one of these jobs come along, you start reinventing the wheel. So I think it needs to be looked at again. I'm too old in the tooth to do it. There you are. There's a job. See?
Thanks.
Yeah. You've just volunteered.
Just one more question in the front.
One more? Or are we at the bar?
The last one. Yeah.
Oh, good. One more last one.
Thank you for your presentation. My question is regarding the project, the Northern Line project.
Yeah.
You mentioned that grey iron segments were replaced by stainless steel segments. Is there a reason why stainless steel segments were used?
A reason why, sorry?
Why stainless steel segments were used?
Yeah, and John, I should collar John in the bar afterwards if you're interested. Has he gone? Well, you'll see him. You can't miss him. He's a big fellow with white hair. The London clay in that area is very pyritic. It's got a lot of pyrite in it. And what little water was in the London clay was turning the pyrite was becoming like sulfuric acid. Pretty strong sulfuric acid too. And it was really attacking the cast iron. The cast iron was really losing thickness and really rotting away. They did look at various options, concrete and being one of them. But it then came back to, we've got to do this during engineering hours because we can't close the Northern Line. So we've got to keep the trains running. Concrete segments are pretty heavy. So they're not easy to handle in that situation. You're in a very confined situation, not much room with the shield. Stainless steel, will not be attacked so easily by the acid water, and even they looked at SGI, but even that would have been attacked. I think they looked at putting coatings on the back of the linings, but the danger is that you get a damage installing it. It's even worse. So you look at the economics of it, and you can then afford stainless steel. So stainless steel, because it kept the weight down, and you were more guaranteed that if you get a decent grade of stainless steel, it'll cope with very acidic conditions. So that was the reason. But if you want to get the grip on that, then John's your man. I think he'd occupied his life for 2 years, did that job.
Thank you. The very last question, please.
That for me? Okay. Thank you for your presentation. I'm just wondering if you can share a bit of your experience with injected waterproofing, because it's fairly up and coming, I suppose, in the grand scheme of things. And I'd just like to...
Injected waterproofing?
Yes.
I haven't got any really. There is a product out there that is used a lot, and it's that I've used is natural cement grout, NatCem. It's very effective. The French use it a lot for injection grouting because it's a French product anyway. It's marketed in this country, but it comes from France. It's a very low shrinkage, very high strength, rapid setting grout. And it's extremely effective in sealing water. It was used extensively on Crossrail to seal leaking contiguous piles, walls. So we just injected this stuff in. Look it up. It's called BTSYM, natural cement. It is a naturally occurring cement. It's got quite a history with it. It goes back to Roman times. It's a particular clay that they mine in Grenoble. It's a very lime-rich clay, and when it's kiln dried and crushed, that's all they do: kiln dried and crush it, and then it's a natural cement. And some surprising things have been built with that stuff. So anyway, that's the only stuff I've come across, and it's often. I'll tell you where it's often used. It's often used to waterproof tunnels before you put spray-on membranes on. So you might wonder why bother with a spray-on membrane, but it's sometimes used in a shotcrete form. Applied, then it stops water seepages long enough to get the spray-on membrane on and let it dry. So the only problem is it's about 4 times more expensive than normal shotcrete or grout. But then, if you're saving money on a job, well, fine.
Let's thank David for a fantastic presentation.